Okay, Jasmine. So can you see my screen now?
Yes, ma'am.
Okay. So we'll be learning about how heat transfer, conduction, convection, and radiation. Okay. So as today we were discussing about how the heat transfer and all that, right?
Yes, ma'am.
So we'll just have a quick recap of that and then we'll move on. Yeah.
Okay, ma'am.
Transfer. Heat always moves from the warmer place to the cooler place. You know it already, right? So if in case you're having a hot water and ice cream, okay, both at the same temperature, okay, so the popsicle, the ice cream or the popsicle will melt and form into a liquid, whereas the coffee will also get cooler and attains the room temperature. This stabilizes, isn't it?
Yes, ma'am.
Yeah, this is what we were seeing yesterday. So now we'll see there are three methods, that is conduction, convection, and radiation. Okay, have you come
Yes,
across
ma'am.
these words earlier?
Yeah, ma'am, not convection.
What?
Ma'am, what not convection, but I heard
Can you
convection.
face the screen and sit so that I can hear you better?
Ma'am, I haven't heard convection before, but I've heard the other two.
Okay, so can you just give me an idea what is conduction?
Ma'am, I don't know.
Okay, so I'll explain you. Okay, you're having a spoon, a steel spoon, and you're heating it in the stove. Okay, so what happens?
Ma'am, it get warm.
Will the spoon remain the same or you will feel the heat?
Ma'am, I would feel the heat.
But the spoon, only the one end of the spoon is being heated. Why do you feel the other hand to be heated?
Ma'am, cause it transfers from warmer to cooler.
Okay, so when you're heating one end, you know the metal is made up of particles. The particles will get vibrated when it is heated. Okay, so when it vibrates, it will pass on the vibration to the particles nearby. So the vibration passes on. So that's why you feel the heat even though you're holding at one end. Okay, this is called as conduction, right?
Okay, ma'am.
So this is what it's, as you heat a metal, the metals will vibrate and it will pass on and along the metal, so it you feel the heat.
Okay, ma'am.
Okay, so can you see this? So when it is the metal is heated, you see the sea of electrons, they gain the kinetic energy throughout the metal. So you know wood and plastic or insulators. What are insulators?
Ma'am, like they do not let heat pass.
Yes, very good. So metal is a good conductor of heat. Now I'll give you an example. So when you're touching, you're having a spoon and your book next to you. Okay, a spoon or a steel plate. So how do you feel when you touch both? How do you feel?
Ma'am, we feel hot
Hmm.
and other ones like not
Why?
meter.
Why?
Because the wood is insulator and the metal is conductor.
Yeah. So the wood will not conduct the heat away from your hand, but the metal will conduct the heat from your body. That's why it feels warmer. Got it?
Yes, ma'am.
Okay, as your, this is convection. Okay, the next one we are going to see is convection. What is convection is a particles in a liquid or a gas, when you heat them, what happens to them?
The particle became less dense.
Yeah, spread out and become less dense. Okay, so can you see, this is the first one, the first image. It's being heated, so the particles will spread out and it is not dense. Okay, it's thinner. So
Okay.
this happens in convection. So this is what. So when you're heating a water, when the water heated, you can see the hot water rises up, isn't it?
Yes, ma'am.
Yeah. So when the water is cooler, it sinks down. So this happens in your fridge. Okay. Where is the freezer compartment in your fridge?
Yes, ma'am.
Where is the freezer compartment?
Ma'am, it is like both
Both.
limited and
It's on the top, right? The first is the freezer compartment, isn't it?
yes, ma'am.
Why the freezer compartment is on the top?
I don't know.
Yeah. So here this principle applies. So the cooler water sinks or the cooler air sinks, it comes down. The hotter air rises up. Okay.
Okay, ma'am.
So when in the fridge, the freezer, the air is cooler, right?
Yes, ma'am.
So it always, right, when you open your fridge, you can find it. When you open your fridge, you can see that white color air like thing gushes. Will it go up or will it come down?
Ma'am, it comes down.
Comes down. Okay. So when you're heating a boiling water, is the water vapor is going up or coming down?
Ma'am, it is going up.
So this makes sense, right? The hot air goes up and the cool air comes always sinks down. Okay, so why the freezer compartment is kept on the top is always the cool air tends to come down. Okay, as it comes down, now the bottom will have hot air, or it comes down and cools the compartments in the down bottom, right? So that is the reason
Yes,
it is
ma'am.
kept on the top. So the same applies when you're having when you're moving into a beach. Okay, there you feel. How do you feel when you go to a beach?
What, ma'am?
When you go to a beach, how do you feel? It's so windy, right?
Yes, ma'am.
Why?
Ma'am, because ma'am, the cooler
So this is what I was telling. Though in the water, how will be the temperature? It will be cooler, right?
yes, ma'am.
So above the air above the ocean will be, the sea will be
Cold.
cold. So I always told you the cold air moves to the warmer place, right?
Yes, ma'am.
So what happens? The land is hot, isn't it? So the
Yes,
cool
ma'am.
air tends to move to the land. So that's why you feel so windy in the seaside. Got it?
Yes, ma'am.
Are you clear?
Yes, ma'am.
So this is what I was explaining about the freezer compartment. Can you just read this?
Yes, ma'am.
Hmm. Read it out aloud.
Yes, ma'am. Where
Yeah.
is the freezer compartment put in a place? It is put at the top because cooler air sinks so it cools the food on the way down. It is warmer at the bottom so this warmer air rises and the convection current is
Now you understood what is convection?
yes, ma'am.
Okay, so now we'll see the radiation. Okay, so how the heat is being transferred from sun to earth. There's no conduction, there's no convection, but radiation is happening. Okay, what do you mean by radiation?
Ma'am, they're like rays. Ma'am,
Yeah,
we cannot see them.
yeah, you're right. So there is the radiation travels in a straight line. They travels even through the vacuum. So they do not need any particles to travel. They travel at the speed of a light. Okay, here is a live example. Okay, emission experiment. So there are four containers. Okay,
Yes, ma'am.
shiny metal, dull black, and shiny black. Okay, so we are going to fill warm water in everything. Okay,
Okay, ma'am.
so now after 10 minutes, which one feels warmer?
Ma'am, dull black.
Why do you say dull black?
Ma'am, because the dark color absorbs the word.
You know that the warm water in the shiny metal will be the warmest because we have already seen that the shiny surface reflects heat. Okay, it takes the heat and reflects it back into the container, so the heat is not lost. But whereas in the black, the dull black, what happens, the black has got the ability to emit heat, so it takes the heat and emits it out. Okay, so
Okay,
the
ma'am.
water inside that will be the cooler. So the next one you will feel, you will understand from this absorption. So again, the four metals, it's kept near a heater in equal distance. It is kept near a heater. So which one will be warmer after 10 minutes?
Ma'am, I think
Sorry.
ma'am, dull black.
Dull black. Why dull black?
Ma'am,
Because it absorbs heat radiation. So that's why we don't wear black colored dresses when it is summer, right? We always prefer
yes,
white or lighter shades. Yes. So have you ever
yes,
watched that the countries where the temperature is too high, the buildings will be painted in a subtle color or mostly white?
yes, ma'am.
It's because they absorb the black will absorb heat, and whereas white it emits the heat. Okay,
Okay, ma'am.
white reflects heat radiation and keeps the house cooler. Okay, why does hot air rise and cold air sinks?
Ma'am, because the cold air goes to the warmer
Okay,
and
we were seeing,
the
right, in the convection, the cool air is more dense, whereas the warm air, it spreads out, the particle spreads out and is less dense. Okay, so it's easy for it
okay,
to uh, move up. Why are boilers
okay.
placed beneath hot water tanks in people's home?
Ma'am, can I go for the water?
We already know that hot water rises up, right?
Yes, ma'am. Ma'am, may I go to washroom?
You want to go to?
Ma'am, washroom.
Yeah, yeah, please be back soon.
Yes, ma'am. Sorry, ma'am. I did.
No problem now. Okay. Now I'll just give you quick worksheet. Okay, you have to work on this
Okay,
worksheet.
ma'am.
before we move ahead to the next.
Okay, ma'am.
The link is in the chat box. You can share your screen as you're doing that.
Okay, ma'am. Ma'am, it is only the Hussein in this meeting.
Oh, I'll log in. I can't see your screen. I can see your screen, but I'm not able to view.
Ma'am, I able to view that now.
I'll make you the host then.
Okay, ma'am.
Yeah.
Ma'am, can you hear now?
Yeah,
Like,
yes.
you know?
No, it's still on the screen. Click on the link.
Okay, ma'am.
Okay, never mind. You can stop sharing it. You do it and just send, click a screenshot of that and present it. Okay.
Okay, ma'am.
Jasmine, done?
Mom, I'm doing.
What happened to the laptop,
Mom,
Jasmine?
too early.
What happened to the laptop?
Mom,
What, ma?
Mom, I don't have it right now.
Okay. Okay, I hope you're done with it.
Mom, only the last point left.
Okay, okay, complete it quick.
Mom, I got 7 out of 10.
Where did you go wrong?
Mom, there were some questions.
Hmm.
Mom, I'll take screenshots.
Yeah, yeah, please send a screenshot. Yeah, I got yours.
Yes, ma'am.
I got it. So you understood. What did you understand from this worksheet?
Ma'am, the temperature and what happens if we melt a metal ball.
Hmm.
Ma'am, and
Okay, fine.
that is
Okay, we'll discuss that later. Okay.
okay, ma'am.
Okay, fine. Now we have to see the measurement of temperature. Okay. Now I'll share my screen.
Okay, ma'am.
So how will you measure temperature? How will you measure temperature?
Ma'am, by the thermometer.
Thermometer. Okay. So these are the standard temperatures. Okay. So room temperature is always 22 degrees Celsius. Body temperature, it's 37 degrees Celsius. Boiling point of water is 100 degrees Celsius. Freezing point of water is 0 degrees Celsius. Okay. These are the standard temperatures that should remember. Okay.
Okay, ma'am.
Just a minute. Okay. So now how will you measure? So for example, your weight, okay, you're using weighing machine to measure your weight, and you say it in the unit called kg, right? Are you listening, Jasmine?
Yes, ma'am.
So what are the three commonly used scales to measure temperature? Can you read it out?
Fahrenheit, Celsius, Kelvin.
Okay, so we'll see what is Fahrenheit. Okay, can you read this? What is Fahrenheit?
Yes, ma'am. Freezing of water occurs at 32 degrees Fahrenheit. Boiling of water occurs at 2 degrees Fahrenheit. Freezing of water occurs at 0 degrees Celsius. Boiling of water occurs at 100 degrees Celsius. Scales state that cold temperature possible absolute zero
Yeah.
bracket minus.
So now what is the difference between Fahrenheit and Celsius? All are measuring temperature only. So why?
What, ma'am?
Why so all are measuring temperature only, but why Fahrenheit, Celsius, Kelvin, all three different scales are given?
Ma'am, because they have like different properties of freezing of water, boiling of water, and Kelvin has a different use.
Yeah, but see, like, but Fahrenheit, it occurs at 212 degree Fahrenheit, okay, whereas it's 100 degrees Celsius. So mostly Celsius is the scale used across the world. Okay, Fahrenheit is mostly used in the laboratories, and also Kelvin. Okay.
Okay, ma'am.
Okay, we'll move on to the next slide. Okay, so this was an early thermometer. Can you see this? Galileo's air thermometer.
Yes, ma'am.
Can you see how?
Yes, ma'am.
So here, when the air gets heated up, the liquid drops. Yeah, the liquids drop and rises when air is cooled. So we are already told, right? The cool air sinks down, the hot air flows up. So this is the principle used in Galileo's air thermometer. Okay. So this is
Okay,
modern
ma'am.
day air thermometer. Can you see
Okay,
this?
ma'am. Yes, ma'am.
This is earlier liquid thermometer. So in the bulb, you'll have the mercury. So it will be just going round and round across the coil. Okay. So each coil, as it moves, it has got a measurement.
Okay, ma'am.
So this is the liquid thermometer. Can you see here? This is mercury. The expansion and contraction of the liquid is used to measure the temperature.
Okay, ma'am.
Now, clinical thermometer is very sensitive, and it will be measuring even very small changes. So that is what used in the present day. Okay, bimetallic strip thermostat. So I'll show you the picture. This is how it looks. Bimetallic, and it's contained with the shaft.
Okay, ma'am.
So this is not required for you. This is infrared thermometer, thermogram. So it's just used to measure, converts the infrared radiation into colors that can interpret the temperature difference. Can you see the temperature difference in the elephant? Can you see the
Yes,
ear? The ear is green in color. It means that there it's a lesser temperature compared to the body.
yes, ma'am.
Yeah.
Yes, ma'am.
Okay. We are done with it. I have to give you one more explanation on this, and we'll move on to this. So this is how the clinical thermometer looks, Jasmine.
Okay, ma'am.
It's in your book. Okay. So a capillary mark tube, it measures the degree and the degree of the temperature. Can you see the reading?
Yes, ma'am.
So can you see here the mercury? And this is alcohol. It moves right away like this.
Yes, ma'am.
Nowadays we use this kind of digital thermometer, clinical thermometer.
Yes, ma'am.
Okay. I hope you got an idea.
Yes, ma'am.
What is ma'am? Yes, ma'am. You're not talking more than that. What happened to you today? You're still feeling sleepy? Are you going to
Yes.
go to school tomorrow?
Ma'am, I didn't want to, but I'll ask my mother.
Okay, fine. Okay, so this is what about temperature. Uh, I wanted to explain it to you. I hope you understood about this. Yeah.
Ma'am, yes, ma'am.
Okay. So transfer of heat is also done. Conduction, convection, and radiation. Okay. So you're going to do
Yes,
a
ma'am.
worksheet on online. I'm going to present that one, and you're going to do that one here, and then we'll move on to your class. I mean to read your books. Okay.
Okay, ma'am.
Cheer up. You're a good girl, no? You always like you have
Yes,
the enthusiasm to study. So what happened to you today? Just cheer up.
ma'am. I came from school, then I had a class, then I had your class, then I related, but then I slept and I the sleep wasn't enough for me.
Yeah, I understand. But then I'll make it more interactive for you. Like I'll make it more engaging for you. It will not be boring. Okay.
Okay, ma'am.
Okay. Let's work on this. Okay. Now, are you ready? I'm
Yes,
not going
ma'am.
to let you alone to do this. I'm going to work with you along with you. Okay.
Okay, ma'am.
Just a minute. I'm sharing the screen. Okay. Can we do this now? Yeah. So you
Yes, ma'am.
remember, conduction is in solid, convection is in liquid and gases, radiation is using waves. Are you clear with this?
Yes, ma'am.
Okay, can we start doing
Yes,
this?
ma'am.
Okay, you have to just
Yes, ma'am.
mark it. Okay, I'll read it for you. Heating a metal saucepan, is it conduction, convection, or radiation?
I'm asking convection.
Darling, I told you conduction is in solids. Convection will happen in liquid and gases.
Yes, ma'am.
So
Fine,
heating
ma'am.
a metal saucepan, it is a
Ma'am, it
metal, it
is
is solid.
conduction.
Conduction, yes. Boiling water in a kettle,
Ma'am, it is convection.
very good. So toasting a bread,
Ma'am, it is conduction.
Okay. Cooking a potato, no, forget the jacket potato. Cooking a potato in a microwave?
Radiation.
Yes. Um, Cooking a potato in an oven?
Radiation.
No, darling. Microwave is radiation, correct. In an oven?
Convection.
No, conduction, because potato is solid, right?
Yes, ma'am.
Hot air balloon? Hot air balloon?
Convection.
What, ma'am?
Convection.
Very good. Okay, so on the next worksheet. Yeah, yeah, read that one.
Ma'am, yes, ma'am. It was required that convection, conduction, radiation. Heat versus temperature. Heat and temperature are not the same. Temperature is a measure of
Hmm. Yes,
how heat or cold something is. It is measured in degrees.
one minute. Yeah, tell me now. Heat and temperature are not the same, right?
Yes, temperature is a measure of how hot or cold
Cold
something
thing
is.
is, it is measured in
It is degrees.
hmm,
And then I don't know what we call it.
Celsius. Okay, Celsius. For example, the temperature of
Celestial.
or temperature of dash water is 100 degrees Celsius. Hmm?
Boiling point.
Yeah, the temperature of the water,
Freezing at least.
yeah, heat is the amount of dash energy something has.
It is something of how
Thermal
hot.
energy. Okay, it's thermal energy. It is measured in joules.
Okay, ma'am.
Okay. Okay. Read the next one.
The amount of thermal energy depends on
Hmm.
the mid. Ma'am, I don't know this one.
Okay, just a minute. I'll just present one more thing for you so that you will understand. One minute now.
Okay, ma'am.
I'll stop share it and I'll share it again.
Okay, ma'am.
And by the
Ma'am,
end of yes,
ma'am, When will the tuition end?
Yeah, I'll end it now. I just want to explain one concept which I missed explaining it to you. I'll explain that and I'll end the class. And by the end of the class, I'll be sending you the solutions for this lesson, heat
Okay, ma'am.
lesson. Okay, you can have it with you, but just try to complete the previous lesson, nutrition. And when you come for tomorrow's class, I want that to be done. Okay, the nutrition.
Okay, ma'am.
And tomorrow we'll read the lesson and we'll have a quick revision of both the lessons, the nutrition and heat lesson. Okay, we are going to have a
Okay, ma'am.
revision, not a test. We are going to revise those chapters thoroughly. And tomorrow is Thursday, right?
Yes, ma'am.
So you will have a test on Friday on these two chapters.
Okay, ma'am.
So you can start preparing now itself.
Okay, ma'am.
Okay, just a minute. I'll just explain this one concept which I missed explaining it to you, and then we'll end the class.
Okay,
One
ma'am.
minute, it's still loading. Yeah. Okay, so I was telling you that heat and temperature are not the same, isn't it?
Yes, ma'am.
Yeah. So we'll see how it is different. Okay. So temperature is always the measure of hot and cold. Okay. It is measured in degrees Celsius, right?
Okay, ma'am.
You know it already. So heat energy means the amount of thermal energy. What is heat?
Ma'am, the amount of thermal energy.
It is measured in,
Joules.
yeah. So here this is a hot cup of tea. The heat energy, it has a kinetic energy of its particles. The particles have kinetic energy. What is kinetic energy?
Ma'am, wait something is moving.
Yeah.
Ma'am, at a speed and it breaks.
Okay, so this is the hot sparkler. Okay, here the temperature is the heat because it's very small, right? The sparkles are very small particles. Though the particles are vibrating, the particles are very less, isn't it? So the amount of heat energy is less, but comparatively, can you see how this is boiling water? Okay, in the hot water bath, the particles will be more. Can you see the particles here in the box?
Yes,
They are
ma'am.
keeping on vibrating, so the transfer of heat is more. Okay,
Okay, ma'am.
yeah, okay. Now it's your
Ma'am,
turn. Yes.
ma'am, I can do that it never touched each other. Like, are not touching. Ma'am, what will happen if like there is no.
I can't hear you clearly.
Ma'am,
Hmm.
so I had a question like I came to know that we cannot touch each other, like there's still a gap in between. And what will happen if it really touched?
Which one?
Ma'am, like the fingers, they still have a like gap, like a little, very little.
Hmm. Okay, so it's because the molecules, the substance that allows you to touch it very closely, the particles are like it's not very smoothly placed. Okay, so that is why you feel a gap in between.
I we we don't touch each other like our cells. They've never touched each other. What would happen if we really touched each other?
Yeah, the transfer of heat will be happening.
Okay, ma'am.
Okay, so the blue flame and the Bunsen burner and the bonfire. You might not have seen Bunsen burner. You can just consider the burner in your stove. Okay, okay, and the
Okay, ma'am.
bonfire. So which one has the most heat? Where you feel when you
Ma'am,
stand next to the burner or the stove, will you feel hot, or when you stand next to the bonfire, you will feel hot?
ma'am, bonfire.
Yeah, so the it has the most heat energy. So which has got the highest temperature? This one I'll give you an example. So in the bonfire, usually they'll cook the barbecues, right?
Yes, ma'am.
Are they cooked very quickly, or it takes hours?
Ma'am, they get cooked quickly,
Is
like
it?
not that
It
long.
takes hours to cook. Okay, in the bonfire. But actually, when your mother cooks in the kitchen, she prepares the meat very quickly, right?
Yes, ma'am.
Yeah. So the which has got the highest temperature, the burner or the bonfire?
Ma'am, the burner.
Burner. So the burner has the highest temperature, whereas the bonfire has the most heat energy. Why do you think like that?
Ma'am, because maybe it is a blue flame.
Yeah, because bonfire, there's a matter. Okay, the wood will be reacting with the, so there's a more particle collision, so the heat has been transferred out. Whereas in the Bunsen burner, already the gas has been fueled up, and so the temperature will be higher. Okay,
Okay, ma'am.
so now look at this. This bottle has got more water and the small beaker has got lesser water. So which one will quick boil quickly?
Ma'am, the smaller one.
Because there's lesser particles.
Yes, ma'am.
Okay, this one you know that. So, transfer
Ma'am,
of heat. This
but
again is the
if
transfer of heat. Okay. So I just want to explain you about heat and temperature are not the same. Okay.
okay, ma'am.
Okay. I hope you understood from this.
Yes, ma'am, I did.
Yeah.
Ma'am,
So
I
I'll be
want to tell
sharing
you
this
something.
worksheet with you. Okay, the one worksheet that I uh, presented to you, right? You were not able to do it. That I'll be sharing it with you. Okay, in the WhatsApp you can do that one, right?
Yes, ma'am.
Okay, you were
Ma'am,
trying to tell something. Yes.
ma'am, if the beaker had like weight, then the water in it would get evaporated
Mm,
faster than the small beaker.
mm. No, I didn't get you. Be louder.
Ma'am, like the beaker, it was like this. If
Mm.
it would have been like this, then the water in it would have been evaporated faster than the small beaker.
Yes. When the mouth is big, the water gets evaporated quickly than in the narrow mouth.
Yes.
Yes. Okay, Jasmine. I'll send you this worksheet and try to remember to complete your work. Okay.
Okay, ma'am.
Okay, darling. So see you tomorrow. Bye. Take care.
Bye, ma'am.
Bye bye.